Okay, today we're going to be looking at um, square roots and cube roots. Those are even and odd radicals. This is a square root. It means the same thing as when you have a 2 in this. This is called the index. So if there's nothing there, it's still actually a square root. It's just two ways of writing the same thing. These are so common that we don't write the 2. So that's what that means. And whenever you have a square root, the question that it's asking is what times itself gives you the inside here. The special thing about square roots is you can't have negatives on the inside because a negative times itself, a negative, will give you a positive. So you wouldn't get a negative in here, and then a positive times a positive, of course, wouldn't give you that. And I'll show you what that means in an example. The cube root, it's the same idea. It just means what times itself 3 times gives you the inside. So a small example here would be the cube root of 27 is 3 because 3 times 3 times 3 is 27. Now you can't have negatives inside a square root or any even root for that matter. So if there's a 4 here, that means like what times what times what times what gives you the inside. You wouldn't be able to have a negative in that either. But with odd, I guess odd indices for like a cube root or a fifth root, you're allowed to have a negative on the inside because if I were to change this to a negative 27, then I think it would be a negative 3, and we can just check it, verify right here. Negative 3 times negative 3 is positive 9, and then times this negative 3, which would give you negative 27, and that's what we wanted on the inside. So negatives are okay in odd roots, but not even roots. And I'll go through a couple examples, probably plenty of examples real quick, and you should be good. So the first one, of course, is just the square root of 4 is 2, and that's the answer. That's because 2 times 2 gives you 4 in there. So the answer is 2, and this is why. This is what I was talking about. You are allowed to have negatives in an odd root, and what times what times what will give you negative 8. So that would be negative 2, because negative 2 times negative 2 times negative 2. That would be 2 times 2 is 4, so negative 2 times negative 2 is positive 4, times the negative 2 is negative 8, and that's what we wanted on the inside. Now I want to make a distinction between a negative on the inside and a negative on the outside. This, if you're following PEMDAS, you can kind of think of this as parentheses. So we do the inside first and then leave the outside. So really, I'm just ignoring this negative on the outside. So the square root of 16 is 4, and then the negative is still on the outside. You could put parentheses around it, but that is okay because the negative is on the outside. If the negative were on the inside for the square root, then you'd say no real solution. Because, so let's do a because, I kind of skipped this one, but we'll go back to it. Because if you say the square root, well, if you say 3, it has to be 3 times itself. You can't have these different. That's not what the square root is asking. It's asking what times itself. So you can't have 3 times negative 3 because then that's not times itself. So 3 times 3 is 9. We wanted negative 9. Well, what if I do negative 3 then? Times negative 3. That also gives me positive 9. So nothing works, no matter what I do. As long as these are something times itself, you'll always get a positive. So there is no real solution in this. There's another way we can think of that later, but right now we're just going to say no real solution. And then the last one, the cube root, I think, what would that be? Just 5. So 5 times 5 times 5, that would be 125. and then tack the negative on in the front. So the answer here would be 5 with a negative in the front. And that's it.